So let's wait for 1 more minute and then start the class, okay? So I think we can start the class. Good evening to Naresh. So as of now, Naresh is the only person present here. Fine. So my name is Anandi, and we were dealing with the aldehydes, ketones, and carboxylic acid lesson. And till the last class, we have studied about the aldehydes and ketones. And I have started with the carboxylic acid preparation part in the last class. Okay. And today I am going to continue with it. So moving on to carboxylic acid and its preparation. And some properties also we are going to see in today's class. So one more student have joined. Okay. So the topics that we are going to see today are the preparation of carboxylic acids, physical properties of carboxylic acids, acidic nature of carboxylic acids, reactions involving breaking of COH bond, and reactions involving the whole COH group, and substitution reactions, and then uses of carboxylic acids. Okay. So moving on to the first topic, which is the preparation of carboxylic acid. So there are 4 to 5 preparations we have, and the first preparation is from primary alcohols and aldehydes. So this is what I have discussed in the previous class itself. Okay, so we are taking a primary alcohol and we are taking an aldehyde, and we are going to treat those primary alcohols or an aldehyde with the following reagents. The following reagents are oxidizing agents. Okay, so who are those oxidizing agents? KMnO4 in basic medium, K2Cr2O7 in acidic medium, and CrO3 in acidic medium. So these three reagents are the strong oxidizing agents which oxidizes a primary alcohol to a corresponding carboxylic acid. Okay. So what is the formula for primary alcohol? It is RCH2OH, and it is getting converted to RCOOH. So here you can see that the number of the carbon atoms remains same in the reactant as well as in the product. Okay. Suppose if we are having R group as CH3, then we would have ethanol as the reactant, and ethanol on oxidation with KMnO4, we get ethanoic acid. Okay, the carbon number remains same in both the reactant and product. So same is the case with K2Cr2O7 also. So potassium dichromate oxidizes an aldehyde to carboxylic acid. Okay. So Here you can see the example which I have given just now. So R group is taken as methyl group here, and methyl group on oxidation forms methanol, that is methyl group containing aldehyde, which is ethanol. Ethanol on oxidation forms ethanol, and ethanol on oxidation forms ethanoic acid. Ethanoic acid. So alcohol on oxidation forms aldehyde. Aldehyde on oxidation forms carboxylic acids. Okay. So this is what we have seen in the last class. Okay, and carboxylic acids are also prepared from aldehydes by the use of mild oxidizing agents like Tollens reagent or filling solution. Tollens and filling solution, those thing we have discussed in the aldehydes and ketones under the test for aldehydes. Okay. So now for today, moving on to the second preparation of carboxylic acid. So second preparation of carboxylic acid is from alkyl benzenes. So what are alkyl benzenes? Alkyl group containing benzenes. So for example, we can take toluene as an example. So toluene contains methyl group as a substituent in the phenyl ring, right? So the vigorous oxidation of alkyl benzenes with chromic acid or potassium permanganate in basic medium forms the corresponding carboxylic acid. So you see here, this is the toluene, and toluene is undergoing oxidation with KMnO4 and it is forming the carboxylic acid. So what is the thing happening here? So in the first part of the reaction, this is the first reaction. Here CH3 group is getting converted to COOH. Okay, this is the conversion which you have to learn. Okay, coming to the second alkyl benzene, which is called as isopropyl benzene. This group is called as isopropyl benzene, and isopropyl benzene on oxidation with same KMnO4 also leads to the formation of C double bond OH. Okay, so here the isopropyl group, the whole group is getting converted to COOH. So whatever might be the alkyl group you have attached to the ring, so that gets oxidized to carboxylic acid. But there is only one exception. So what is that exception? Only primary and secondary alkyl groups are oxidized. Tertiary group containing system will not get oxidized to carboxylic acid. So what is meant by tertiary alkyl group system? Suppose if I am having C6H6 like this, and if it is attached to a tertiary butyl group. So what is tertiary butyl group? A carbon attached to 3 different alkyl groups is called as what? 4 different alkyl groups is called as tertiary carbon. So you see, this carbon is tertiary. This carbon is tertiary. So the tertiary carbon which is attached to the phenyl ring, it cannot be oxidized to the carboxylic acid on treatment with KMnO4. Why? Why tertiary carbons are not getting oxidized? Because tertiary carbon doesn't have the hydrogens attached to it. So what is oxidation? Addition of oxygen or removal of hydrogen, right? Since we do not have hydrogen attached to the tertiary carbon, this tertiary carbon cannot be oxidized to the carboxylic acid. Okay. So in methyl benzene, here in methyl benzene or toluene, what we have? We have a carbon which is attached to 3 different hydrogen. In case of isopropyl benzene, what we have? We have a carbon which is attached to 1 hydrogen. Okay. So what is this? This is the secondary carbon. And in case of primary carbon containing system also, we have hydrogen. So what is primary carbon? So if a carbon is attached to, if I have CH2, CH3. If a carbon is attached to only 1 methyl group or 1 alkyl group, or if a carbon is having 2 hydrogens attached to it, it is called as primary carbon. Okay. So what is the concept? If a carbon is attached to 3 hydrogen, it is called as methyl group. If a carbon is attached to 2 hydrogen, it is primary. If it is attached to 1 hydrogen, it is secondary. And if it is attached to zero hydrogen, it is tertiary. So methyl primary and secondary carbons can be oxidized, while the tertiary carbon containing benzenes will not get oxidized to the acid. Okay. So do you have any doubt here in this preparation of carboxylic acid from alkyl benzene? If you have any doubt, you can let me know in the chat box. Otherwise, I'll move on to the next preparation. If the concept is clear, just type S in the chat box so that I can understand that you are listening and the concept is clear to you. If it is clear, just type yes, students. Yes. Thank you so much, Nandini. Okay, good. So I have the preparation. That is the preparation of carboxylic acid from nitriles and amides. Yes, thank you. Thank you so much, Prabhakar. Good. So from nitriles and amides. So what are nitriles? Nitriles are CN containing compounds. They are the cyanide group containing compounds, which is otherwise called as nitrile. So nitriles on treatment with acid H plus or a base. We can do acid hydrolysis or base hydrolysis. And this acid or base hydrolysis of nitrile leads to the formation of amide. This is called as amide. Okay. So here CN group is getting converted to C double bond O NH2, which is called as amide group. Okay. Then this amide on further hydrolysis with acid or a base and on strong heating, it forms the corresponding carboxylic acid. Okay. So here the NH2 group is getting converted to OH group. Okay. So this is the mechanism. CN is getting converted to CONH2 and CONH2 is getting converted to COOH. Okay. So basically this compound is called as amide and this is called as nitrile. So what you can do, you can start from nitrile and you can attain carboxylic acid, and you can start from amide also to get the carboxylic acid. Got it? This is the mechanism, and let us see one example to understand this. So I have took ethane nitrile as an example. So where R group is the CH3 group. And since we have 2 carbon here in the system, it is called as ethane nitrile. So this ethane nitrile on hydrolysis, on acidic or basic hydrolysis, forms CH3CONH2. CH3CONH2, which is called as ethane amide, as it contains 2 carbon. Okay. And then ethanamide on further hydrolysis, what happens? It forms the 2 carbon containing ethanoic acid, CH3COOH. Okay. So this is the preparation of carboxylic acid from nitrile or amide. Got it? So just learn the mechanism alone. Cyanide on hydrolysis forms amide. Amide on hydrolysis forms acid. Okay. So whatever might be the R group, you just have to write the same R group in all the products. Okay. So is there any doubt here in the third preparation of carboxylic acid? Or if it is clear, just type yes. Okay. Thank you. Thank you, Paul. So I'll move on to the next preparation. That is from acyl halides, acid anhydrides, and esters. So what is the formula for acyl halide? It is RC double bond OX. Okay. Let us see one by one. So in all the 3 reactants, we are going to do acid hydrolysis. That is reaction of water in presence of acid. It is called as acidic hydrolysis. Okay. So first we took an acyl halide, RCOCl. Okay. So this is the water and we are doing acidic hydrolysis here. And on acidic hydrolysis, this Cl will be converted to OH. Cl will be converted to OH. That is RCOCl on acidic hydrolysis on acidic hydrolysis forms RC double bond OH. So here, whatever might be the halogen attached to the carbonyl carbon, it is getting converted to OH. Okay, with the release of HCl. This is from acyl halide. Then next from acetic anhydride. So you can see the acetic anhydride formula here. It is RCO twice O, which is, I'll expand the structure for you. It is RC double bond O, O, C double bond O, R. So this RCO part is taken two times and we are having an oxygen attached to it. Okay, this is the acidic anhydride. And this acidic anhydride on treatment with water in presence of acid, it forms 2 moles of carboxylic acid. So how does it forms the 2 moles of carboxylic acid? So we are going to add the water into it. So how we are going to add the water into it? Just break one of the CO bond, either this bond or this bond you break, add hydrogen to oxygen and OH to the carbon. Got it? So in water we are having H plus and OH, right? So you add the H plus to oxygen and OH minus to the carbonyl carbon. So what you will get? You will get RCOOH in one side and the another mole of RCOH is formed here. So basically 2 moles of carboxylic acid, they are getting prepared from the acidic anhydride. Okay? Got it? And coming to the third reactant, which is ester. So what is the formula for ester? It is RCOOR. RCOOR. So both the R can be same or it can be different. If it is different, then we can take one as R and the another one as R dash. Okay. So here is the ester, and this ester on acidic hydrolysis forms a carboxylic acid and an alcohol. How are we getting here? Here you have to break the CO bond. Okay. So break the bond and add water in this manner. Always you have to add the OH minus to the carbonyl carbon and H plus to the oxygen. So we get a carboxylic acid and an alcohol. Got it? Only the reactant differs. H2 and H plus, they are same. And the product, one of the product is same. Only the byproduct differs. Got it? So these are some of the examples. So what is this? C6H5COO C2H5. So this is basically an ester, right? So what is the name of this ester? It is ethyl benzoate. So C6H5 C double bond O O C2H5. So this is the alkyl group, which is ethyl. So it is ethyl benzoate. What we have to do? Break this bond, add OH here and H here. So what we are getting? We are getting benzoic acid and ethanol. Okay. So we are getting a benzoic acid and ethanol part. Basic hydrolysis gives alcohol and carboxylate ion. So instead of using acid here, if we are using a base OH minus, we would arrive at an alcohol and a carboxylate ion. Instead of this carboxylic acid, we would get C6H5COO minus ion, which is called as carboxylate ion, if we are doing a base hydrolysis. Okay. The remaining things are same. So do you have any doubt here in this reaction? If you're having any doubt, just let me know. I'll repeat the thing. Or else you can take down and type S in the chat box so that I can move on to the next reaction. Students, if it is clear to you, just type S or it is clear. I'll move on to the next reaction. Thank you, Nandini again. So I'll move on to The fifth reaction, thank you so much for both of you. And coming to the fifth preparation of carboxylic acids, that is from Grignard reagent. So what is the formula for Grignard reagent? It is RMgX, right? So RMgX on treatment with carbon dioxide, which is called as dry ice. This carbon dioxide is called as dry ice, where it is an example of a carbonyl carbon. See, double bond O group is present there, no? So it is an example for carbonyl system. And this on treatment with acidic hydrolysis leads to the formation of RCOOH. So how we are getting a carboxylic acid from Grignard reagent? Let us see the mechanism to understand this. It is very easy, okay? So first we are taking a Grignard reagent, and then we are taking the second reactant, which is carbon dioxide. So here the alkyl group is the partially negative group and MgX is the partially positive part. What you do, you break one of the C double bond O bond, add the negative part to the carbon and the positive part to the oxygen. You will get this kind of intermediate. So I'll add for you. Just listen. Add the R to the carbon and MgX to the oxygen. So what we are getting here? We are having an RC. One C double bond O is there. One C double bond O is there. So here they have added here to this carbon. I have added here. No matters. Okay, both are going to give you the same intermediate. So and OMgX bond is formed. And this OMgX on acidic hydrolysis forms the carboxylic acid. So here you have to break the OMg bond, break this OMg bond, add hydrogen here, H here and OH here. So what you will get? You will get RCOOH in one side and MgOHX in the another side. Okay. So this is the mechanism. So it is called a step-up reaction as the number of carbon atom increases in the product. So in the reactant, we are having only one carbon in the carbonyl system. But in the product side, you're having a carbon and also some carbons which is attached to the COOH group, that is alkyl system. Okay. So if the alkyl group, if the R group is CH3, if the R group is CH3, what we would get here? We would get CH3COOH, right? So here we are taking CO2, which contains only one carbon, and at the end we are getting two carbon. So where does this carbon come from? It has come from the Grignard reagent I took. So since the number of carbon atom increases by the number 1 or number 2, etc., it is called a step-up reaction. Got it? So see the example here. I took ethyl group as an example. Ethyl group is as an example. And how to add this ethyl group to the system? Just break the bond, one of the C double bond O bond, add the R group, that is CH2, CH3 to the carbon and MgCl to the oxygen. So what is the intermediate we get from here? We get C double bond O and here CH2, CH3, here oxygen, and to this oxygen MgCl is added. So O minus MgCl plus. Okay. Then this on hydrolysis. This on hydrolysis, that is H plus and H2O, forms the carboxylic acid. What you have to do? Just break this OMg bond, add H here and OH here. So you'll get the CH3, CH2, COOH system, which is called as propanoic acid. This is called as propanoic acid. So we took ethane magnesium chloride or ethyl magnesium chloride as an Grignard reagent, and we got propanoic acid as the final product. Okay. So this reaction was asked in NEET 2022. The question was like this. So they gave the RMgX they gave RMGX, and they gave CO2. And they have asked to find out X here. And this X on further hydrolysis, it forms RCOH. They have asked us to find out the X. So what is the X here? It is actually C double bond O, C double bond O. We would break this bond and we would have added R group here and MgX here, no? So what is the X group actually? It is R, C, OO minus and MgX. So this was the answer to this question. Such an easy question, right? This was asked in NEET 2022. Okay. So is the concept and mechanism clear to you? If it is clear, just let me know in the chat box. Yes. Thank you, ma. Thank you. So these are the 5 preparations. 5 preparations for the preparation of carboxylic acid. Okay. So first we used oxidizing agents, and secondly we used alkyl benzenes, and thirdly what we used, what is the third reaction? Third reaction was from nitriles and amides. Fourth is from acyl halides, anhydrides and esters, and fifth is from Grignard reagent. Okay. So next we are going to see the physical properties of carboxylic acids. So what are the physical properties? So lower fatty acids up to carbon number 10 are colorless liquids, but the higher ones are colorless waxy solids. So if the carbon number increases, the physical nature also increases. It changes. That is, it is changing from liquid to solid. Okay. And the first 3 members have a sharp pungent odor. What is pungent odor? Having bad smell. Okay. And the carbon number 4 till carbon number 9 have an odor of rancid butter. Rancid butter is nothing but the oxidized butter. So you get a smell of oxidized butter if you are taking butanoic acid till decanoic acid, that is from carbon number 4 to 9. Whereas higher members do not possess any smell. So more than 10 carbon containing carboxylic acid will not have any bad pungent odor. Okay. And coming to the solubility, lower members are highly soluble in water. That is, you can take till carbon number 4. Methanoic acid, ethanoic acid, propanoic acid and butanoic acid. Till 4 carbon, they are soluble in water. But the solubility decreases with rise of the molecular mass. So what is the relation between solubility and molar mass? Solubility is inversely proportional to molar mass. If molar mass increases, solubility decreases. Because the R group, the alkyl group length increases. The length of the alkyl chain increases so that it will not allow the carboxylic acid part to form the bond with the H2O molecule and get dissolved in it. That's why the higher members are insoluble in or it is slightly soluble in water. Okay. Now coming to the next, boiling point. So next physical property is boiling point. So carboxylic acids are higher than those of alcohols of same molecular mass due to intermolecular hydrogen bonding. So far till the last aldehydes and ketones topic, we have discussed that alcohols is the alcohols are the compounds which has the highest boiling point. Okay, now you see carboxylic acids are even having higher boiling point than alcohols because of intermolecular hydrogen bonding. What is intermolecular hydrogen bonding? The hydrogen bonding which exists between 2 molecules. Okay, between 2 molecules, if you are having a hydrogen bond, it is called as intermolecular hydrogen. So you see the compound which I gave here. So what is the name of this compound? CH3COOH. ethanoic acid. So I took 2 moles of ethanoic acid, and between these two molecules, there is a hydrogen bonding present, which is called as intermolecular hydrogen bonding. And since each compound is able to form 2 hydrogen bonding, so hydrogen bonds are basically strong. So if a compound has to get boiled, it has to break all the hydrogen bonding present inside it, and then only a substance or a liquid will boil. Okay. So the bonding is very strong so that it cannot break. That's why carboxylic acids are having higher boiling point compared to the alcohols, aldehydes, ketones, etc. Got it? So is the physical properties clear till the 4th point, which I have discussed? Shall we move on to the next property? Yes. Thank you, Kirtana. Thank you. So I'll move on to the structure of carboxylic acid. So what is the structure? It is RC double bond OOH. This is the structure, and we are going to study some information about the structure. So you can see the RCO bond angle is 120 degree. So why it is 120 degree? Why it is 120 degree? The hybridization of this carbon is sp2. Why it is sp2? Because the carbon is a double bonded carbon. If an atom is having 2 bonds attached to it, that is, if it contains a double bond, then the hybridization would be almost sp2 only, right? So if the hybridization is sp2, then the structure is trigonal planar. The name of the structure is trigonal planar. So if the trigonal planar is the geometry of a substance, then the corresponding bond angle value would be 120 degree. These informations you would have studied in your 11th standard, right? 11th class you might have studied this. So that's why the bond angle is 120. Everywhere it is 120. Here also it is 120, and there also it is 120. So everywhere it is 120. Got it? And the CO single bond length is 1.32 angstrom. It is 1.32 angstrom, and the OH bond length is 0.97 angstrom. So these are the values you have to study. So the bond length mentioned is for formic acid. So what is the formula for formic acid? If the R group is hydrogen, H, then the name of the acid is formic acid, right? So the formula for formic acid is HCOOH. So the bond length varies slightly with the attached alkyl groups and the substituents. Okay. If the alkyl group, if the R group is methyl, or if it is ethyl, then we would have some difference in the bond length, which I have given here. Got it? So this is for formic acid. So here, the lone pair which is present on the oxygen is getting delocalized. So the oxygen lone pair shifted to the carbon, and those electrons which is present there in the double bonded system is getting transferred to the oxygen which is there at the terminal. And from this, we are getting one more resonance structure for this carboxylic acid. So these two structures are the resonance structures of carboxylic acid. Okay. So just shift the electrons here, and automatically the electrons which is there between C double bond O will get shifted to the oxygen. So you will get O minus since the electrons are getting shifted there. And since oxygen electron has been shifted here, oxygen has got the plus charge there. Got it? So these two are the resonance structures of carboxylic acid. Okay. So the main very important information are the hybridization and the geometry, the bond angle, and the resonance structure. Okay. So bond lengths, just you have to understand. That's it. So is the structure of carboxylic acid part clear to you all? Shall we move on to the next topic? If you have noted it down, just let me know in the chat box. I'll move on to the next topic. Thank you. So the next topic is the chemical properties of carboxylic acids. Okay, under the chemical properties only, we are going to see some few reactions. So the first reaction is based on the acidic nature of carboxylic acid. So basically, carboxylic acids are acidic in nature. So why they are acidic in nature? When they are treated with water, they forms the carboxylate ion and H3O plus, which is called as hydronium ion. Okay. So here water acts as a base. Means RCOOH is acting as an acid. So what is an acid? H plus donor are called as acid, right? So here you see the carboxylic acid has donated its H plus to the H2O, which is a base. Or we can say this base has accepted this hydrogen so that the electrons are shifted to oxygen. You can tell in either of the ways. So acids are proton donors and bases are proton acceptor. So since carboxylic acid is donating its H plus, it is called as an acid and it is acidic in nature. And again, the electrons which is present on the oxygen get shifted and the delocalization of pi electrons occurs here, and this forms one more carboxylate ion structure. These two are the resonance structures of carboxylate ion. So again, this comes here and the electron goes back and you will get a first structure again. So this is the first resonance structure I can say, and this is the second structure. And if I want to write both the structure in a single structure, I can write like this, no? So these two are called as resonance structures and this is called as resonance hybrid. This is called as resonance hybrid. So resonance hybrid exists in the reality, whereas resonance structures do not exist in the reality. Just for our understanding, we are shifting the electrons like this using pen and paper, but in reality, resonance hybrid only exists. The delocalization of pi electrons will always be there between the three atoms. That is one carbon and two oxygen. Negative charge will get delocalized over the three atoms all the time. Got it? So that's why resonance hybrid exists in the reality. We are saying. And carboxylic acids are weaker than mineral acids, but they are stronger acids than simple alcohols and phenols. Okay. So what are mineral acids? HCl, H2SO4, HNO3. So this kind of hydrochloric, sulfuric and nitric acids are called as mineral acids. Now our COOH, carboxylic acid, is weaker acid compared to these three, but they are stronger acid. Why does carboxylic acid show acidity? Because of the more electronegative carbon oxygens attached to the carbonyl carbon. Because of the two electronegative oxygen atoms attached to the C double bond O system. Okay. Got it? Yes. So they are stronger acids than alcohols and simple phenols. They are stronger acids than alcohols and simple phenols. So you see here, if this R group is an electron donating group. So who are electron donating groups? All the alkyl groups like methyl, ethyl, propyl, and what else we can say? OH, OCH3, all alkoxy, alcohol, all these are electron donating. Amine, all these are electron donating groups. If the electron donating group is attached to the C double bond O system, then that particular carboxylic acid is less acidic in nature. Why it is less acidic? Since we are donating the electron here, the carbonyl carbon, this carboxyl carbon or carbonyl carbon, it is getting more electron rich. center is getting more electron rich. So electron rich species are basically called as bases, right? So it is getting basic, or we can say the system is less acidic. Okay. And if an electron withdrawing group is present, so who are electron withdrawing groups? They are NO2 group, CHO group, and ketone group. So ester group, all these are electron withdrawing. So they will withdraw the electrons from the C double bond. So basically what happens at the end? The electron density here decreases. So it becomes more electron deficient. So electron deficient species are called as acids, right? So acidity increases. Acidity increases. Got it? Is the acidic nature of carboxylic acid concept clear to you all? If it is clear, just let me know. So the last concept which I have discussed here is very important. An electron donating group is attached, it is less acidic. If electron withdrawing is present, it is more acidic. Because you will get questions from this concept. Like they will give you 3 to 4 compounds in which you'll have electron donating group in one compound, electron withdrawing in another compound, like that. And they will ask you to arrange the given compounds in the increasing or decreasing order of acidity. Okay. So those are very important. So is the concept clear? Yes, it is clear. Just a second. We'll do a question, okay? Consider the acidity of the carboxylic acids, the most acidic is. So this is one of the previous year JEE question. So what we have to do, we have to find out the most acidic carboxylic acid given in the 4 options. I will give you 10 to 15 seconds. If you would have got the answer, just put that in the chat box. Then we will discuss the answer here. So 4 different options are given to you. One is pH. What is phenyl? It is benzoic acid. So this is benzoic acid. C6H5 group is called as phenyl group. So this is given in option 1. Just a second. So this is option 1, benzoic acid. And in the second option, what we are having? We are having orthonitrobenzoic. So this is benzoic acid. And to the adjacent position, which is called as ortho position, we are having a nitro group. So this is orthonitrobenzoic acid. So what is the third compound? Third compound is para-nitro. So what is para-nitro? You have to attach the nitro group in the opposite position, opposite to COOH. So this is para-nitrobenzoic acid. And the last compound is meta-nitrobenzoic acid. Meta-nitro means alternative to the COOH. So this is meta-nitro. So we have to find out the most acidic compound among these 4. So have you got the answer? Has anyone got the answer for this question? If you have got the answer, just let me know in this chat box. Okay. The correct option is 2. The correct answer is option 2. Because you see, we have nitro groups attached in all these compounds. Who are these nitro groups? Electron withdrawing or electron donating? Tell me whether they are electron withdrawing or electron donating. They are electron withdrawing groups. So, if an electron withdrawing group is attached to the adjacent position to this carboxylic acid, already this carboxylic acid is acidic. No? Why it is acidic? Because on losing its H plus, it is forming a more stable carboxylate ion. That's why they are acidic in nature already. And if an electron withdrawing group is attached to in the adjacent position to the COOH, it withdraws the electron density from the carboxylic acid more effectively. So what happens? The compound gets more electron deficient in nature. But in case of para and in meta, nitro groups are just a little bit far away from the COOH group. They will also withdraw the electron, but not that effectively as the ortho compound does. Okay, so that's why orthonitrobenzoic acid is more acidic in nature, since they are very near, adjacent to the COOH group. Okay. Got it? Do you have any doubt? Is the question clear to you all? So carboxylic acids, they are acidic in nature because of the donation of H plus more effectively. And one more thing we can say, on donation of this H plus, they are forming the carboxylate ion. They are forming the carboxylate ion. And this carboxylate ion, it is getting stabilized through resonance. We have seen, no? And we got two resonance structure. We got two resonance structure, and through this resonance, they are getting stabilized. And that's why on donation of this H plus, this carboxylate ions are getting stabilized by resonance, and that's why they are acidic in nature. Since because of the formation of more stable carboxylate ion. Got it? Is this clear? Shall we move on to the next concept? Okay. Well, let us discuss the reactions due to this acidity of carboxylic acid. So we have seen that the hydrogen which is attached to the carboxylate part is acidic. They are acidic hydrogen. So there are several reactions due to acidity of carboxylic acid. So this is the acidic hydrogen. When the carboxylic acid reacts with the metal called sodium, we can take any of the alkali metals or alkaline earth metals you can take. So on reaction with the metal, it forms a corresponding carboxylate ion. So here it is forming the sodium carboxylate. This is RCOO minus and Na plus with the evolution of hydrogen gas. Okay. So what is happening here? R C double bond O OH is there, and this on treatment with sodium, this O-Na bond breaks. That is, the hydrogen goes out, H plus goes out, and we are getting R C double bond O minus ion, and to this sodium is going and forming the ionic bond. Got it? Since we are taking 2 moles of carboxylic acid, we are getting 2 moles of sodium carboxylic part here, and 2 hydrogen, they are going out as hydrogen molecule. Okay, just replace the hydrogen with sodium, that's it. So this is the example you can see. So I took 2 moles of ethanoic acid and it forms sodium ethanoate, and it forms sodium ethanoate. Now coming to the next reaction. So this is the first reaction and this is the second reaction. So carboxylic acid on treatment with sodium hydroxide. Sodium hydroxide is a base. Sodium is a metal. And sodium hydroxide is a base. So here what happens? The product remains same. The product remains same. Sodium salt of carboxylic acid we are getting. But the another product is the removal of H2O. Byproduct is the removal of H2O. So again here in this carboxylic acid also, which bond cleaves? the OH bond gets cleaved and it is replaced by, hydrogen is replaced by sodium with the release of H2. Got it? So just see the example. Here I took propanoic acid. Propanoic acid on reaction sodium hydroxide. We get sodium propanoate as the salt and H2O is going on. Got it? So on reaction with the metal, hydrogen gas is evolved. On reaction with the base, water molecule is coming out. But the other product, the main product remains same for both. Got it? Shall we move on to the next reaction? Okay, the next reaction is the reaction of RCOOH with NaHCO3. So what is this? Sodium bicarbonate. Sodium bicarbonate is also a base, but it is a weak base. Sodium bicarbonate is a weak base. So the reaction of carboxylic acid with a weak base forms sodium salt of carboxylic acid as one of the main product with the release of carbon dioxide gas and H2O. Okay. So let us see some more points about this reaction. So you see here there is a beaker and in this beaker the reaction occurs. There is a brisk effervescence of carbon dioxide gas coming out from the container. You can see, right? So you can see there is a brisk effervescence of carbon dioxide coming out. It goes out as a gas. In the reaction mixture, we would have only the RCOONA and H2O part. So you can separate the carboxylate part using separating mixtures and all. Okay. And this reaction is used to differentiate between phenol and carboxylic acids, as phenol does not react with NaHCO3 because it is less acidic than acid. So since sodium bicarbonate is a weak base, it will not react with the phenol. Okay. Phenol is also a weak base. Phenol is actually less acidic in nature, which can be otherwise called as weak base. So a weak base cannot react with another weak base. Only acid reacts with base, right? So two bases cannot react with each other. So what they are doing, they are using this reaction to differentiate between phenol and carboxylic acid. If I put a phenol here, the reaction doesn't occur. If I put a carboxylic acid here, the reaction occurs because carboxylic acids are having more acidic nature due to the more stable carboxylate ion getting formed. Okay. So there is an example given here for this reaction where ethanoic acid is taken as the reactant and it is treated with sodium bicarbonate and it forms the sodium salt of ethanoic acid with the evolution of carbon dioxide and H2O. So these three are the reactions under the acidic nature of carboxylic acid. So what is the summary? If I take sodium, I am getting H2 as the byproduct. If I am taking NaOH, H2O is the byproduct. If I am taking NaHCO3, which is a strong base, I am getting H2O and CO2 as the byproduct. So these are the byproduct differentiation. Main product is same for all the three. Got it? Is the reaction clear to you? Shall we move on to the next reaction? If it is clear, just type S. Next part is reactions involving the breakage of COH bond. I think time is up. So what I'll do, I'll just conclude the today's class for now and then start the next topic in the next class tomorrow. Okay. So just to summarize the part. So firstly, what we have seen. Firstly, we have seen five preparations of carboxylic acid, and then we have discussed some physical properties of carboxylic acid. Thirdly, I have discussed some structure related information of carboxylic acid part, and then moving on to the chemical properties, we have discussed the acidic nature. So the why carboxylic acids are more acidic and the reactions due to acidity of carboxylic acid. Okay. So in the next class, we can continue the chemical properties. Mostly we can conclude this lesson by tomorrow and then start a new lesson. Okay. So students, is all the concepts which I have discussed clear to you? If you're having any doubt, you can ask me. If all the concepts are clear, then just type yes. I'll close the today's class. I'll give you 10 to 15 seconds. If you're having any doubt, just let me know. Yes, everything is clear. Okay, thank you so much, Srinivas, for your response. Okay, students, then I'll meet you all in the next class. Thank you so much. Thank you. Take care.